Hi friends, welcome to this session of maths. Today we are going to look at exponents and roots. So what exactly are exponents? Exponent basically means how many times a number is multiplied with itself. So for example, here you say you have 8 into 8 is equal to 8 square. So this is called an exponent. X into x, 8 into 8 into 8 is 8 cube. So 3 is called the exponent. In an expression of an exponent, 8 raised to 3, 8 is called the base, that is the number that is multiplied with itself, and 3 is called the power. So what this means is 8 multiplied with itself 3 times. Negative exponents, how many times to divide 1 by a number. So you are dividing 1 by a particular number. Let's say in this case 8 raised to minus 2. So what I am doing is I am dividing 1 by 8 and then again by 8 because it is 8 raised to minus 2. So 2 times I have to divide 1 by 8. So what I get is this. So you will also see that 8 raised to minus 2 is also same as 1 divided by 8 raised to 2. Right? So 8 raised to minus 2 is equal to 1 divided by 8 raised to 2. So we get this general formula a raised to n is equal to 1 divided by a raised to n. Some basic rules. Any number raised to 0 is 1. Any number raised to 0 is 1. 78 raised to 0 will be 1. 1, 2, 3, 4 raised to 0 will be 1. 1 raised to any number is 1 itself. So 1 raised to any number is 1 itself. That is because how many ever times what is 1 raised to n? 1 raised to n means 1 into 1 into 1 into 1 n times. What is going to be that product? That product is going to be 1 anyway. So 1 raised to n is 1. Any number raised to 1 is the number itself. Let's say any number raised to 1. That means multiply a with itself once. That doesn't mean this. It means multiply a with itself twice. So this is not correct. What we are doing is multiply a with itself only once. That means it is only a. So any number raised to 1 is going to be the same number. Let's see here 78 raised to 1 is 78. 1, 2, 3, 4 raised to 1 is 1, 2, 3, 4. Any number raised to minus 1 is the reciprocal of the number. What have you seen on the earlier slide? Any number raised to minus 1, a raised to minus n is going to be 1 by a raised to n, right? So a raised to minus 1 is going to be 1 by a raised to 1, which is going to be 1 by a. That means any number raised to minus 1 is going to be the reciprocal of the number. Let's see here 78 raised to minus 1 is 1 by 78. 1034 raised to minus 1, I'm sorry, this is a typo. 1234 raised to minus 1 is equal to 1 divided by 1234. Some laws of exponents. X raised to m into x raised to n. Now these laws are fairly straightforward. X raised to m into x raised to n. So that means what we are saying is I have x into x into x like this. I have n m times and then I multiply that by x into x into x n times. So when I look at the whole product, what do I get? I have these many n's. This is m times x, this is n times x. That means totally I'll get x into x into x, this for total of m plus n times. That means x raised to m into x raised to n is equal to x raised to m plus n. This is the first law of exponent. Let's see for an example, x square into x3 is x raised to 2 plus 3, which is going to be x raised to 5. Similarly, x raised to m divided by x raised to n. So I have in the numerator I have x into x into x how many times? I have it m times, and in the denominator I have x raised to x raised to x, how many times? N times. So you will see that all these x will get cancelled. What will remain in the numerator will be m minus n times x, which is going to be equal to x raised to m minus n. So we get this rule: x raised to m divided by x raised to n is x raised to m minus n. Let's see for an example. X raised to 6 divided by x raised to 2 is x raised to 6 minus 2 is equal to x raised to 4. The third rule: x raised to m raised to n is equal to x raised to mn. Let's look at this term. What do we have? X raised to m, that means x multiplied m times, this is m times x raised to m raised to n. Okay, that means the whole thing multiplied n times with itself. That means what do we get is x into x into x, like this, m times multiplied by x into x into x into x second time. This is the first time. This is mx, and like this we continue for an entire of n times. That means how many x's we have totally? These are m x's in one row and n such rows. That means we have totally m into n rows, which is equal to x raised to mn. So that is why we get x raised to m raised to n is equal to x raised to mn. Example: x raised to 2 raised to 3 is equal to x raised to 2 into 3, which is x raised to 6. Similarly, x y raised to n is equal to x raised to n y raised to n. Let's look at this. What do we mean by x y raised to n? We mean xy into xy into xy, like this, n times. Now this xy itself is a product, right? So it is x into y into x into y into x into y, like that, n times. So you will see that there are n x's and there are n y's. So we get x into x into x n times into y into y into y n times, right? So what is this expression? This is x raised to n. What is this expression? This is y raised to n. So ultimately what we get is x y raised to n is equal to x raised to n y raised to n. Let's see an example. X y raised to 3 is going to be x raised to 3 into y raised to 3. X divided by y raised to n. Similarly, we are going to get x raised to n divided by y raised to n. X divided by y raised to n is x into y divided by y, x divided by y, x divided by y, like that, n times, which is same as x into x into x n times divided by y into y into y n times. That means it's going to be x raised to n divided by y raised to n. Let's see an example. Xy raised to 2 is x square by y square. X raised to minus n is equal to 1 divided by x raised to n. We have already seen this. Example: x raised to minus 3 is equal to 1 by x raised to 3. X raised to m divided by n. Now this is interesting. X raised to m divided by n. So x raised to m divided by n is also written as x raised to m into 1 by n, right? So we are basically using this rule. X raised to m into n is x raised to m the whole raised to m. So 1 by n, we know, we call 1 by n is the root. So what it means is the nth root of x raised to m, which can also be written as, first you take the root and then you multiply, because here it doesn't matter which order we are following. We can also write it as x raised to 1 by n the whole raised to m, because ultimately both m and 1 by n will get multiplied, and what we'll get is this. So it doesn't matter whether you take for x raised to m first or x raised to 1 by n first. So that is why we have two expressions, nth root of x raised to m or nth root of x raised to m. Let's look at an example. X raised to 2 by 3 is x square and the third root of x square, or third root of x the whole square. Roots. The nth root of a number is the number that gives original number when multiplied n times. So when we talk about square root, what do we mean by square root? Let's see, square root of 4 is 2. Let's only consider a positive 2 case. X square root of 4 is equal to 2. So what does it mean? So that means when you consider 2 and multiply with itself, how many multiplications we are doing? We are doing only 2 multiplication. Why? Because this is the square root. That means it's the second root. What do we get? We get 4. Let's look at the third root, cube root of 27. We get 3, right? We take that cube root, we multiply it thrice. What do we get? We get the original number 7. Cube root is the third root, that is why we multiply it by twice. So the nth root of a number is the number that gives the original number when multiplied n times. For example, square root of 9 is 3. Square root is a number that gives the original number when multiplied twice. Cube root is the number that gives the original number when multiplied thrice. Square root of 27 is 3. Similarly, square root of a negative number is going to be negative. Square root of positive, cube root of a negative number is going to be negative, and square root of a positive number can also be negative. This is one of the numbers, whereas cube root of a negative number is always negative. Square root of a positive number can be negative, or rather there are two square roots, whereas cube root of a negative is only one and it is always negative. Nth root of x is also written as x raised to 1 by n. That is what we saw on the previous slide. So square root we can write at square root of 4, we can write it like this, or we can also write it like this, 4 raised to half. So let's look at this practice problem. Please pause the video and see if you can solve this. Okay, so what we have here is an expression, and we are supposed to find out the value of this expression. So we have under root 25 plus 10 root 6 plus under root 25 minus 10 root 6. Let's say this value of this expression is k. Now what we'll do is, because we have these under roots, we'll need to get rid of these under roots. So what we'll do is we'll square the entire expression. So what we get it, k square is equal to, notice that this is of the form a plus b. So a plus b square, which is a square plus b square plus 2ab. So what do we have? A square 25 plus 10 root 6 a square plus b square 25 minus 10 root 6 plus 2ab plus 2 times under root 25 plus 10 root 6 into under root 25 minus 10 root 6, right? So we get k square equal to, this under root and this square get cancelled. So what we get is 25 plus 10 root 6. Same thing here, this under root and this square will get cancelled. So what we get is plus 25 minus 10 root 6 plus 2 times the whole under root, because both these expressions are under roots, so we can club them. What we get is inside and the whole under root we get 10 25 plus 10 root 6 into 25 minus 10 root 6, right? You'll see this 10 root 6 getting cancelled. 25 plus 25 is 50. 50 plus 2 times the whole under root of 25 plus 10 root 6 into 25 minus 10 root 6. You'll see that this is a plus b into a minus b. So a plus b into a minus b is a square minus b square. So what we get is 25 square minus 10 root 6 square, which is equal to 50 plus 2 times under root. What is 25 square? 25 square is 625 minus 10 root 6 square. Now when we have 10 root 6 square, it is going to become 10 square into root 6 square, which is 10 square is 100, root 6 square is 6. So 100 into 6 is going to be 600. So what we get is k square is equal to 50 plus 2 times under root 25. So you'll see that under root 25 has two values. It could be positive 5 or negative 5. So we'll consider both the values. So we'll say 50 plus or minus 2 times root 5. Oh, sorry, root 25, which is 50 plus or minus 2 times 5. Correct? So what do you get? 50 plus or minus 10, which is 60 or 40. So this is k square. We need value of k. So what we do is we just take the square root. So we say k is equal to plus or minus root 60 or plus or minus root 40. Let's look at this problem. Please pause the video and see if you can solve this. If 27 into 9 raised to half divided by 81 raised to 3 by 4 is equal to 9 raised to 2 minus x, what is x? See, the concept here is that all these need to be expressed as a power of a basic number, of a prime number. Okay, so we'll see that 27 is what? 3 raised to 3 into 9. 9 is what? 3 raised to 2, the whole raised to 1 by 2 divided by 81. What is 81? It is 3 raised to 4. 3 raised to 4 divided by 3 divided by 4. Sorry, 3 raised to 4 raised to 3 by 4 is equal to 3 raised to 2 multiply raised to 2 minus x. Right, so now everything has been expressed in form of 3. Let's further simplify this. What do we have here? 3 raised to 2 into 3 raised to 3 into 3 raised to 2 is 3 raised to 5. So we get 3 raised to 5 into 1 by 2. So 3 raised to 5 by 2 divided by 3 raised to 4 into 3 by 4. So it's going to be 4 into 3 by 4. We are going to get only 3 raised to 3 is equal to, this is going to be straight multiplication. So this is 3 raised to 4 minus 2x, right? 2 into 2 minus x. So what do we get here? We get here 3 raised to 5 by 2 minus 3 raised to 3, or rather sorry, this is not 3 raised to 5. What do we get here is so what do we get here? We get 3 raised to 5 by 2 minus 3 raised to 3. This is a raised to b divided by a raised to c. So the whole expression will be a raised to b minus c is equal to 3 raised to 4 minus 2x. Okay, so what is this going to be? 5 by 2 is 0.25. 0.25 minus 3 is minus half. So what do we get? This indicates that minus half, 3 raised to minus half is equal to 3 raised to 4 minus 2x. Now we have both the bases as 3, so we'll just equate the powers. So what we get is minus half is equal to 4 minus 2x. So that means we get 2x is equal to 4 plus half, which is 9 by 2. So x becomes 9 by 4. So here by getting all these terms to a common base and then equating the powers of on both sides of the equation, we get x is equal to 9 by 4. Let's try to solve this problem. Okay, the trick here is that we'll try to get one common term outside. These are very big numbers, but you will see that there is a particular pattern. We'll be able to get a number outside. So which number do we find outside? We'll always find the lowest number, lowest power of a number. So this is 2 raised to 99. So let's get 2 raised to 99 outside. 2 raised to 99. What is 2 raised to 100? 2 raised to 100 is 2 raised to 99 into 2 raised to 1, which is 2. 2 raised to 101. If you take 2 raised to 99 outside, you'll get 2 raised to 2. Similarly, from here if you take 2 raised to 99 outside, you'll get 2 raised to 3. From here you will get 2 raised to 4. So this is what we get in the numerator. In the denominator, if you take 2 raised to 99 outside, we get 1 plus 2 plus 2 raised to 2 plus 2 raised to 3. Correct? 2 raised to 99 gets cancelled. What we get is 2 plus 4 plus 8 plus 16 divided by 1 plus 2 plus 4 plus 8. Right, so what do we get here? This is 6 plus 14, 8, 14 plus 16 is 30, and 30 divided by 3, 7, 15. What we get is number 2. Let's see this problem. Please pause the video and give it a try. If x is equal to fifth root of minus 245, so x is equal to fifth root of minus 245, you will see that it's an odd root and of a negative number. Odd root of a negative number is always going to be odd. So x is less than 0. This is one observation we have. You'll also see that if you look at this number 245, you will see that it is very close to 243, which happens to be the fifth root of which happens to be fifth power of 3. So that means 243 fifth root of 343, 243 is going to be 3, right? And fifth root of minus 243 is going to be minus 3. Correct? Okay, now we have x is equal to fifth root of minus 245. So this x is going to be very, very close to minus 3, and it is going to be greater than minus 3 or less than minus 3. Numerically 245 is higher than 243, so that means numerically the root will also have to be the greater than 3. So that means it is going to be greater than 3, but when it is negative, it is going to be somewhere on the left side of minus 3. In numerically, that means in absolute value, it is going to be greater than 3. In the sense, it is going to be somewhere 3.1 or 3.2 or something like that. And because it's on the negative side, it is going to be less than minus 3. So this is one observation we have. Okay, so now which of the following is true? Root of minus x is greater than 3. Let's assume, for sake of simplicity, that x is equal to minus 3.1. Let's assume it's going to be somewhere close. So root of minus x is going to be under root of minus x is going to be 3.1 under root of something like 3.1, whether that is greater than 3. So we know that root of 3, this is going to be very close to root of 3, which is 1.7. So this is going to be somewhere again close to 1.7, and 1.7 is not greater than 3. So this cannot be true. Second option, x greater than minus 3. We already know that x is less than minus 3. So this option cannot be true. X cube less than minus 27. So what do we have? X cube is minus 3.1 cube. What is that going to be? So it's going to be definitely less than minus 3's cube, right? Because it's going to be numerically higher and it's going to be negative. So that means it's going to be smaller than minus 3's cube. So what is minus 3's cube? Minus 3's cube is 27. So that means we can say that x cube is going to be less than minus 27. So this expression will always be correct. Let's look at the fourth one for the sake of understanding. X raised to 4, that is going to be minus 3.1 raised to 4, something greater than 243. What is 243? 243 is 3 raised to 5. Right? So what we are saying is 3.1 raised to 4 is greater than 3 raised to 5. This is not going to be, this minus will get cancelled because we are talking of the fourth power. So this minus doesn't matter. So what we are saying is something slightly greater than 3, the fourth power of that is greater than the fifth power of 3. Now this is not going to be true. So this is also not true. So answer here is C. Let's look at this problem. Please pause the video and see if you can solve this. Okay, this is a quantitative comparison problem. X minus y, whether that is greater or x minus y raised to 2 is greater. So you may tend to think that because this is the square, this is going to be a bigger number, but that is not always true. If x minus y is 0.5, in the sense if y is here and x is here on a number line and the difference between them is only 0.5, then you will see that 0.5 into 0.5 is going to be 0.25. So this x minus 5 is 0.5, x raised to 2 is 0.25. Which one is greater? X minus y is greater. Now let's see if x minus y is equal to 4. If x minus y is 4, x minus y raised to 2 is going to be 16. In this case, x minus y raised to 2 is bigger. So we cannot actually make any decision. So the answer would be cannot be solved. Let's look at this problem. If x is equal to 256 raised to minus half plus 625 raised to minus 1/4, which of the following is an integer? Okay, so let's see. X is equal to 256 raised to minus half. Now raised to minus half, we know that a raised to minus n is equal to 1 by a raised to n, right? So that means we'll write it as plus x raised to 1 by 4. So using this logic, that a raised to minus n is equal to 1 by a raised to n, we'll rewrite both the terms. We'll write that 256 raised to minus half is 1 by 256 raised to half plus 625 raised to minus 4 is 1 by 625 raised to 1 by 4. Right? Okay, so what is, now we'll use another rule. We know that a raised to 1 by n is actually the nth root of a, correct? So 1 by 256 raised to half means 1 by square root of 256, and 1 by 625 raised to 1/4 is square root of 625, correct? So what do we get? We get 1 by 16, 256 square root of 256 is 16, plus 1 by square root of 625 is 25, square root of 25 is 5. So this is what we get. So this means it is 5 plus 16 by 80, which is 21 by 80. This is the value of x. So x is equal to 21 by 80. So which of this is going to be an integer? 21x is going to be 21 into 21 by 80. This is not an integer. 80x is going to be 80 into 21 by 80. 80 and t get cancelled. This is going to be 21. So yes, this is an integer. X divided by 21 is going to be 1 by 80. It is not an integer. X divided by 80 is going to be 21 by 80 into 80. That is also not an integer. X itself is going to be 21 by 80, which is not an integer. So answer here is B, 80x. Let's look at this problem. Please pause the video and see if you can solve this. In which case is x smaller than y? Okay, so let's evaluate all these options one by one. Here what we have is 0.7 raised to x is equal to 0.7 raised to y. Now you will see that the base in both the exponents is same, so that means we can equate the powers. So that means what we get is x is equal to y. So x is not smaller than y. This option is ruled out. This option, same thing, we can equate the powers because base is same. So what we get is x is equal to 2y. Now you may think that x is equal to 2y, so x is smaller than y. It is not always true. If y is negative, let's say if y is equal to -1, so x is going to be equal to -2, and you will see that x is less than y. So x is equal to 2y does not necessarily say that x is smaller than y, or x could be 0, y could also be equal to 0, right? So this is also not a case where we can always say that x is smaller than y. Let's look at this third option, 0.7 raised to x greater than 0.7 raised to y. Now you may be tempted to believe that because bases are same, the same inequality will hold true in terms of the powers. So you may conclude that x is greater than y, but that is not always true because the base here is less than 1. So let's look at two, just to make this point clear, let's look at two numbers. We'll square both the numbers and we'll see what kind of relationship exists between a number and its square. Let's say we choose two numbers, one is smaller than 1, one is greater than 1. Okay, let's square both of them. So what do we get here? We get 0.25, 0.5 into 0.5 is 0.25, 2 into 2 is 4. Now you will see that out of these two numbers, the original number being 0.5, original number and its square, which one is higher? You will see that the original number is higher, right? Out of the numbers here, the base number is 2, the power, second power of the number is 4. Which one is greater? This power is greater. So you will see that whenever the number is greater than 1, the square or third root or the fourth root, any positive root is going to be greater than that number. Whereas when the number is less than 1, any positive root, square, cube root, square of a square, is going to reduce the value of the original number, and hence the original number will tend to be greater than any of its positive powers. So here also, that means this inequality we cannot directly apply. In fact, we will have to reverse the inequality. So because this is 0.7, what we can say is that x is going to be smaller than y. Let's, for the sake of understanding, let's evaluate d and e also. 7 raised to x equal to 7 raised to y. Bases are same, bases is greater than 1. So we say x is equal to y. This is not, does not indicate that x is smaller than y. 7 raised to x greater than 0.7 raised to y. Now you will see that 7 raised to x, so always going to be, at least for positive values in x and y, is always going to be greater than 0.7 raised 0.7 raised to y. Also, we can have any any values for x and any value for y. There is not any definite relationship between x and y. Let's say for example we have 7 raised to x and 0.7 raised to y. We can always have x as 2, right, and y any number, any positive number, which is going to exhibit this relationship, because then x raised to 2 is going to be 49, and any positive power of 0.7 is going to be less than 49. So in this case, this we'll realize that for x is equal to 2 and y is equal to any positive number, this relationship will always hold true. So this any positive number could be 2, it could be 1, it could be 3, anything. So you will see that there is not any definite relationship between x and y. So we cannot say anything about x and y from this statement. So the answer here is D. So thanks for watching this video. I hope you learned a good deal about exponents and roots, and I look forward to meeting you in the next session. Thank you.